Hi, my name is Anirban Mandal. I'm from RENCI at UNC Chapel Hill. Today I'll be talking about our work on leveraging distributed research cloud infrastructures for domain science research. So this is joint work with my colleagues at RENCI. Paul Ruth is here, with Eva Dillman's group at USC ISI. Michael Zink and Eric Leons are here. They're from UMass, and Ivan Rodero at Rutgers. So one of the major challenges for data-intensive applications is the integration of data into the whole scientific workflows that the scientists go through while doing the discovery of whatever process they're going through, right? So the challenge is how to move the data across diverse infrastructures, from instruments, from data repositories, into the computing platforms which actually do the analysis for the scientific tasks. How do you support complex workflows? How do you manage the elasticity of the requirements from the application side, the compute requirements, the storage requirements, the network requirements? So what we're doing in this work is we're developing some new algorithms and mechanisms that offer optimized data flows across diverse national cyber infrastructure resources. We're developing dynamic multi-cloud resource provisioning across Genie clouds, across NSF cloud resources like Chameleon Cloud, Exceed resources like Jetstream clouds, and also we have done an initial integration with resources from the Massachusetts Open Cloud that we heard today morning. We're also developing a network-centric platform to bridge what we call as the abstraction gap. So it's really hard for scientists to use any of these advanced infrastructures connected through layer 2 networks, having multi-cloud distributed resources, right? So it's very hard for them to use them for their particular application use cases. So we are trying to develop a platform that bridges this abstraction gap so that it's easier for them to use the resources. We're also working on developing some data-aware scheduling algorithms so that we can map these applications effectively on these infrastructures. And we are deploying the solutions in the context of observational science use cases. And I'll be talking about one of them as a part of this talk. So for these applications, they express their requirements in the form of a Gantt chart, right? So they can express how much compute, storage, and network resources are needed for the application workflow at every point of time it's needed. And this Gantt chart abstraction is input into the network-centric platform that we call Mobius, which does the underlying resource provisioning across its multiple cloud resources, does the network orchestration by doing layer 2 network provisioning, and it exposes a REST API to the application and the workflows so that it's easy for the applications to actually provision the end-to-end infrastructure. So one of the applications that we're working on with Mike's group is the CASA application, which is called Collaborative and Adaptive Sensing of the Atmosphere. So traditionally, the high-power, long-range Nextrad radars, they even though they're high-power and long-range, they have very limited ability to observe events which are closer to the ground, right? It's because of the Earth's curvature. So what the CASA radars do is, the CASA system, they deploy a network of much smaller radars, but they can actually observe events which are closer to the ground, right? And there are 7 such radars deployed in the Dallas-Fort Worth area. So, and they can observe events like the hail, high winds, and tornadoes, which affect the society to a large extent. And another interesting thing about the smaller radars is based on the weather events that they observe. The weather analysis could drive the observation in a different way. It could turn the radar in a different way depending on the current observations. So as a part of this project, we ingest data from the CASA radars, and we I've developed multiple of these CASA workflows, which do different kinds of weather simulations for responding to different kinds of weather events in the Dallas-Fort Worth area. The system that we deployed as a part of this project, which we call as the Dynamo project, is used operationally by the CASA scientists for real-time weather predictions. And this slide shows how we deployed a distributed research cloud for the CASA applications. We demonstrated this infrastructure at the Supercomputing Conference last year, where we used multiple research clouds from the ExoGenie testbed, which is one of the Genie testbeds, and we have also used one of the NSF cloud testbeds, the Chameleon cloud sites. We brought the radar data to the show floor at SC, and we ran the simulation across these multiple cloud sites using dynamic multi-cloud provisioning with the Mobius system. So this slide shows the particular configuration that we used. This shows more of the details of the configuration. We use distributed testbeds, which are heterogeneous platforms. We use the hardware from ExoGenie and Chameleon. We had the radar data repository at University of North Texas, and also a copy of that was on the show floor. And it shows the kind of integration that's actually required end-to-end for running these workflows in an operational sense. This shows a science example of a particular hail workflow that we executed using our system, where the CASA radar data were ingested from the radar data source, radar data repository into the execution platform across these multiple test beds, and we had the Pegasus workflow management system deploy these different applications on different parts of this multi-cloud infrastructure. And this workflow was run or was executed automatically on that infrastructure. And the figure on the right shows the output of the analysis, of the weather analysis that was done on the execution platform. It shows the orange contour shows the hail contour, and the red one is the wind contour. And this map actually is overlaid on actual physical infrastructures like hospitals and other important places, so that the emergency managers can use this output to avoid certain areas for emergency management. Currently, we're working on optimizing some of these data flows across multiple infrastructures. We're working on active monitoring and control. We're trying to support a larger federation of clouds, including Amazon EC2, Cloud Lab, and OCT. We're also working on data-aware workflow scheduling and deploying more CASA workflows, and we're also working on supporting streaming data. So that gives an overview of where we're going, and thank you.